Okay, pre-cal students, kind of a long lesson today. We'll get through it as clearly and concisely as we can, but there's a lot to cover here. So we're looking at law of cosines. So like law of sines, law of cosines applies to any triangle. You can see that it's a little more complicated. So here's one form of it in triangle ABC, c squared equals a squared plus b squared. So that much just looks like Pythagorean theorem. C squared equals a squared plus b squared. But then we have this extra part minus 2 times a times b cosine of angle C. Or we can, we're going to use this form if we're trying to figure out what a side is. If we're looking for an angle, cosine C is equal to a squared plus b squared minus c squared all over 2ab. And really you can substitute around any of the letters. It does not have to be, C here. We could say, for example, if I wanted to find out what b is, then I would say b squared equals the other two letters, a squared plus c squared, minus 2, and it has to be these two letters, ac, cosine of, the angle has to be the same as whatever side here, so cosine of capital B, and that's it. That's it for that. Okay? Or, likewise, if I was looking for b, cosine B would be equal to a squared plus c squared minus b squared over 2ac. Okay? So it does not have to be strictly c. You can solve for any side, any angle. All right, so we're going to do a quick little derivation here of where this comes from. So I've got this triangle ABC. It's a little bit more complicated. Yesterday when we did this, we just had H here, and we called this side B, and this side A, and this side C. But now we're going to divide up these right triangles. And so I'm going to call the side to the right, we're going to call this X over here. And if this is X, and knowing that this whole side is B, then this part over here is B minus X, right? The whole thing minus X gives us B minus X here. Okay? So, c squared, little c squared right here, I'm going to use the Pythagorean theorem to start off here. So I'm going to say this is equal to b minus x squared, this part, plus h squared. Okay? So I'm going to expand my b minus x squared. That's going to be b squared minus 2bx plus x squared plus h squared. All right? Now, this over here, x squared plus h squared, x squared plus h squared by the Pythagorean theorem must equal a squared. So I can rewrite this as b squared minus 2bx plus a squared. All right. Now I'm going to replace x. So I know that, just out to the side here, I know that cosine of c, the cosine of c is adjacent. I'm using this right triangle, the right side of this big triangle is a right triangle. It's adjacent over hypotenuse. Cosine of c equals x over a, multiply both sides times a, and I get that x equals, a's are going to cancel, x equals a times cosine c. All right? So I'm going to move this a squared up in front. It's a positive a squared. That gives me a squared plus b squared minus 2 times b times x, and I just said x was a cosine c. So now I'm just going to rearrange, all these things are being multiplied, I can rearrange them a little bit, and I can say a squared plus b squared minus 2 times a times b cosine c. And that is the first version of the law of cosines. All right, so for the second version, version 2 up here at the top of the page, I'm simply going to solve for cosine c. So first thing I'm going to do is it's minus 2ab cosine c. I'm going to add that over to the left to make it a positive 2ab cosine c. And on the same step, I have equals a squared plus b squared, and I'm going to subtract the c squared that was over here on the left. I'm going to move it to the right by subtracting it, so I'm going to have minus c squared. And now, my last step, I'm going to divide both sides by 2ab. And my 2ab will cancel on the left, and that gives me cosine c equals a squared plus b squared minus c squared over 2AB. Almost went off the page there. Okay? All right. So let's use it. So, law of cosines can be used to solve triangle problems where we have two sides and the included angle is known, or all three sides are known. So when we're talking about, if I'm talking about two sides and included angle, that would be like little a, little b, and angle c that comes between those two sides. That's what we mean by the two sides and the angle, the included angle. So it's the angle between two sides that we know, all right? Or else that we know all three sides. Okay, so let's draw a triangle here, and let's see if we can figure this out. So I've got B is 35 degrees. I've got A is 5 and C is 6. So let's say that this is A is 5, and let's say C equals 6. So this is going to be angle C, this is going to be angle A, and this is little b. Okay? And we're trying to figure out what B is. All right? So, using my law of cosines, but for B, I'll say B squared equals A squared plus C squared minus 2AC cosine of angle B. All right? A squared plus C squared has to be the same two letters here. Whatever I have here, that's going to be my angle here. So plugging in my numbers. B squared equals A squared, 5 squared, plus C squared, 6 squared, minus 2 times 5 times 6, cosine of 35 degrees. All right. If I put all that in the calculator, 5 squared plus 6 squared minus 2 times 5 times 6 times cosine 35 degrees. All this gives me that B squared is approximately 11.851. I'm going to leave it in the calculator. I'm going to take the square root, and then second negative to get my last answer in here. So this will be a little bit more accurate than rounding. So B is approximately 3.443. 3.443. Okay? All right. So that is using your law of cosines right there. Okay. Now we've got triangle ABC. And this time we have three sides. So I'm going to say this is 5, this is 6, and this is 10. So this is my A, this is my B, excuse me, and this is my C up here. I'm looking for angle A. All right? So cosine of A equals my other two sides squared and added together minus the side opposite, whatever angle I'm talking about, over 2BC. So let's plug our numbers in. B squared, that's going to be 5 squared, plus C squared is 6 squared, minus A squared is 10 squared, divided by 2 times 5 times 6. Okay? So if I put this in the calculator, I'm gonna make a fraction out of this. I hit math and left arrow to get to frac, and press enter. Now I've got a fraction. 5 squared plus 6 squared minus 10 squared. And then on the bottom, 2 times 5 times 6. Negative 13/20ths is what I'm getting here. Negative 13/20ths. All right, so I'm going to do inverse cosine of that. So the fact that my cosine is a negative value should tell you something special here. That tells you that this is an obtuse angle. It's greater than 90 degrees. It's in the second quadrant. So second cosine, second answer, and I'm getting 130.5 degrees. 130.5 degrees. Okay? All right. So, important note. Law of cosines and law of sines can be used to solve non-right triangles. All right? We can use both of these to solve non-right triangles. Now, remember, law of sines cannot distinguish between acute and obtuse angles because Both quadrant 1 and quadrant 2 angles have positive ratios for sine. Sine is positive in both the first and in the second quadrants, and so it really can't distinguish between those. Law of cosines can, though. Law of cosines can distinguish between acute and obtuse angles because if it's in the first quadrant, cosine is positive. If it's in the second quadrant, cosine is negative. All right? So when solving for the angle, if there is any possibility that the angle is obtuse, it's greater than 90 degrees, do not use law of sines. All right? Because it's going to give you, if you do inverse sine, it's going to give you a first quadrant answer. Remember that the largest angle in a triangle will always be located opposite the longest side. So if you're so that means, what that means is, if you're looking for the biggest angle, it's best to use law of cosines. You should use law of cosines because for sure that will tell you if it's obtuse. If it's any of the other two angles, those cannot be obtuse. You can only have at most one obtuse angle in a triangle. All right? The middle angle, the smaller angle, they have to be less than 90 degrees, so they're fine to use law of sines. And we certainly would rather use law of sines than cosines just because it's so much simpler. Okay? All right, so let's look at what we're talking about here. A triangle has sides of lengths 15, 6, an angle of 50 degrees. So let's see if we can make this. So I've got a pretty long side here. I've got a shorter side here. So this is my 15, this is my 6, so this is my C, this is my B, and this is my angle A that is 50 degrees. Okay? Solve for the missing part. So first thing I'm going to have to do is find little a. All right? So I'm going to say a squared equals b squared plus c squared minus 2bc cosine a. All right, my b is 15, so 15 squared. C is 6, 6 squared, minus 2 times 15 times 6, cosine of 50 degrees. So putting this in the calculator, 15 squared plus 6 squared minus 2 times 15 times 6, cosine 50 degrees. I'm getting about 145.298 for a squared. I'm going to take the square root of that, and I get 12.054. 12.054. Okay, so approximately 12.054. Now, at this point, I've got both A's, and so I can start using law of sines. Notice that the biggest side is 15, which tells me that B is the biggest angle. So it's possible that B is obtuse. That is a possibility. So, because I want to use law of sines, I am going to solve for C. Because I know this will not be obtuse. It has to be smaller than 50 degrees, in fact. Okay, and then once I have those two angles, I can figure out what B is. So here we go. So I'm going to say sine C over 6 equals sine 50 degrees, my A, over little a, 12.054. So sine C equals 6 times sine 50 divided by 12.054. So 6 sine 50 divided by 12.054. And I'm getting 0.3813. I'm going to do inverse sine of that, and I got 22.4 degrees. And so my last thing I need to find is B. B plus 22.4 plus 50 is equal to 180. So that's going to be 72.4, 180 minus 72.4, and sure enough it is obtuse, it's 107.6. Okay? If I had actually tried to use law of sines for B, look at what would have happened. Okay, I know that the answer is actually 107.6. If I'd actually done this, I would have said sine B over 15 is equal to sine 50 over 12.054 Okay? I would have had 15 sine 50 divided by 12.054. All right? Gives me 0.953. I would have done second sine of that, and I would have gotten 72.4. I would have had b is equal to 72.4. It should have been 107.6. The problem is, if I do sine of 72.4, I get 0.953. If I do sine of 107.6, which is what b really is, I get the exact same thing. Because 72.4 is the reference angle for 107.6. This is 180 minus 72.4. That's what it is. All right, so this would have been the wrong answer, and I would have gotten, it should have shaken out. You know, you should have figured it out pretty quickly, because you would have had 72 here, you would have had 50 here. That would have been 122, 122.4, and you would have said 180 minus 122.4 is 57.6 for this angle for C. Well, that angle should have been bigger than A though, but the side is clearly only half as big as A. So at that point you should say, oh, wait a minute, something's wrong here. Okay? All right, enough said about that. The answer was 107.6. That is the correct answer. Let's go on. Last one. Find the length of the median to the longest side. I've got AB is 15, BC is 30, AC 24. So the median is the line that goes from the opposite vertex to the middle of the opposite side. So here's, let's say that's about the middle. What I'm looking for is the length of this line segment right here. And so these two pieces are equal. And since I know that this is 30, then they are both 15. So far, so good? All right. First thing I'm going to do is I'm going to find angle B. And you could do it by finding angle C just as easily. All right? But I'm going to find angle B. So I'm going to say B squared, excuse me, cosine B. I'm going to use, I have the three sides. I'm going to use the big triangle here to find, I'm going to find B using the whole triangle. That's step one. Whole triangle. Okay. So cosine B is equal to a squared plus c squared minus b squared divided by 2ac. All right? So a squared is 30 squared plus c squared, 15 squared, minus 24 squared, divided by 2 times 30 times 15. So math, I'm going to make a fraction here. 30 squared plus 15 squared minus 24 squared. On the bottom, I have 2 times 30 times 15. And I've got 61 over 100. So B is inverse cosine 61 over 100. Inverse cosine 61 divided by 100. 52.4. Okay, got 52.4 degrees. Now, I'm going to just look at this small triangle here. I've got 52.4 degrees here. So now I'm going to think of this as a small triangle, and I've got two sides in the included angle, so I'm going to use step 2. I'm going to find, let's call that M. I'll find M using small triangle, the left triangle here. Okay? So, I'm going to say, M squared equals 15 squared plus 15 squared minus 2 times 15 times 15 cosine 52.4 degrees. Okay? So, all right, we're going to say 15 squared plus 15 squared minus 2 times 15 times 15 times, and I know cosine of this angle is 61 over 100, actually. That's actually going to be more accurate. So I've got this, and then I take square root of that, and I've got 13.248. All right, so look at that. Does that look reasonable? This is 13.248. Yeah, that seems about right, I guess, you know. Looks like it's going to be less than 15 probably. That seems okay. All right. That's it. Sorry that was a long lesson. We will hope you have a good weekend. We're wrapping this up. We only have 2 more lessons left. And I will talk to you on Monday. Have a good one.